So the next paper that we are going to see is coming from Canada. We really appreciate to have the submission from the research affiliates from Canada in that conference. Thank you for joining our conference. The paper that we are going to see, it is entitled Quantitative Assessment of Machine Tools Condition through Fractal Analysis of Volumetric Error Vector Similarity Measures. The authors are Kanglin, Xing, Xavier, Rimpault, John Mayer, Jean-François, Chatelain, and Sofiane, Achiche. Thanks for submitting. We are looking forward to the video presentation.
Hello everyone, my name is Kanglin Xing. I'm a PhD candidate in mechanical engineering. I'm from Polytechnique Montreal. Today I will present my research work, Quantitative Assessments of Machine Tools Condition through Fractal Analysis of Volumetric Error Vector Similarity Measures. 5-axis machine tool has been widely applied in modern manufacturing owing to its great capability in manufacturing complex parts. The key ability to produce good parts is the machine tool's symmetric accuracy. Symmetric accuracy can change due to the factors such as the wear and tear, and also the undetected, unexpected events. Therefore, symmetric accuracy is frequently measured to establish machine capability, to prevent making bad parts, and also to set CNC compensations. Then here comes one question. Can we use this for predict maintenance? To use symmetric accuracy for 5-axis machine tool condition monitoring, we need to select the possible monitoring objective. Symmetric accuracy can be classified as symmetric errors and volumetric errors. Volumetric error contains not only the estimated symmetric error, but also some unknown symmetric errors which are not modeled in the 5-axis machine tools. Take this model as an example. The modeled volumetric error contains the modeled symmetric error parameters. However, for the real 5-axis machine tools, the measured volumetric error contains not only the modeled symmetric error parameter, but also some unmodeled symmetric error. So the measured volumetric errors are a good objective for machine tool condition monitoring. Currently, methods such as the vector similarity measure, principal component analysis, control charts, K-means, and also the combined vector similarity array has been used for volumetric error data processing. But these methods are just focused on the single volumetric error data processing. So, can we use some quantitative measure for volumetric error condition monitoring? And this is the target of our research. The data processing including the 3 main steps: volumetric error acquisition, volumetric error data processing by vector similarity measures, and then those data will be processed by the Fractal analysis. As for the volumetric error data acquisition, we will use the scale and masterboard artifact Samba method for volumetric error measurements. The setup and the raw measurements of Samba method are as follows. 4 masterboard artifacts and 1 scale bar are inserted on the machine tool pallet, and the touch trigger probe will be installed on the machine tool spindle. And the total measurements will last for 100 minutes. And during the measurement, 27 angular positions relative to the BC axis are set, and in the end 109 probing positions are get. Finally, after the Samba data processing, we get 8 inter-axis error parameters and 3 axis linear gains, and the 2 offsets of the spindle, and also the masterboard coordinate. And in the end, we also get the 109 volumetric error vectors, which are from 109 probing positions. After the Samba measurements, we can find that for each probing position, we can have 1 volumetric error vectors, and in 109 probing position, we get the vectors which would be shown in this position. And those volumetric error, we need to get the features of the volumetric error vectors. And here we introduced 4 kinds of parameters vector similarity measure parameters, module, cosine, array, and volume parameters to get the picture. Volume is defined as the norm of the volumetric vector, and cosine calculates the angle between the vector and the z-axis, which is a specific axis. And then we use array parameters. Array and volume parameter consider the effect of the distance and also the angle. And we use array parameter to calculate the array and the vector, and also the volume parameter, which the calculation can be found here. After the data processing of the vector similarity measure, we are aiming to using fractal analysis to extract the feature of volumetric error. Fractal analysis can estimate the fractal dimensions and other fractal characteristics from a data set in a variety array of signs. Fractal analysis are selected owing to its high relative robustness and the high degree of automation. Fractal analysis rely on the conversion rate of data size S. The SI in this research is defined as a volumetric error similarity measures, and they are with different triangle size keynotes, GA, and a fly function which is defined and a fly functions which has a weight of A. Then, SA is assumed to have a finite length, which is named as LA. This equation. Finally, the regularization dimension. Fractal dimension estimation can be calculated by this equation, it means D. The range of the scope determination is selected after primary evaluation, and the scope definition is here. And finally, in this research, we will use the fractal parameters D, G, R square, and index. Index is a combined parameters which consider the effect from the DG and R square. After the introduction of the fractal analysis measures, here we will introduce the logic for vector similarity measures and volumetric coordinate data processing. In this research, we are more focused on the fractal analysis of vector similarity measure, which include the module, cosine, array, and volume parameters. In addition, we also introduce a volumetric coordinate. This volumetric coordinate can provide another data set, defined as like S, which I have introduced in the last slide. And this has been used in our previous research, and it also get good results. To verify the performance of the fractal analysis of vector similarity measures, we introduce here as a reference, and we will compare vector similarity measure and this one after the fractal analysis, and to compare its performance. To test our proposed concept, we're using the volumetric data from the three perspectives. It includes the real data. Real data are measured frequently from our 5-axis machine tools. And during our frequently measurements, we met a real C-axis encoder fault. A C-axis encoder fault is generated by the encoder drawback. And after that, we remove the encoder, then the machine tool is controlled by the linear axis encoder. And this can lead to the change in volumetric error. And in addition, we also introduce the pseudo force. Pseudo force contains two types. One is linear position error EXS, and another is UX. And the way to generate the two kinds of force are we using the error compensation methods. We inject the error into the compensation tables. Here, compensation table or machine tool. Then we use the summer method to measure the machine tool, and we get the volumetric error. Another thing is we modify the raw testing result. The frequently measured result will be processed by those equations to introduce the EYX errors into into the original machine and to generate the pseudo fault. So in the end, 3 kinds of faults are used for the concept testing. After the data processing, we get the following results. In this slide, it reveals the CSS encoder fault processing result. From here, we can find that different performance of Fractal analysis of volumetric error vector symmetry ledger could be found. And area and volume measure perform better than the module in the changing port detection, and the exact changing port are in the 13th position. However, for the cosine parameters, it doesn't work. The changing port doesn't detect it. When it's come to our reference, volumetric coordinates, Fractal analysis process the volumetric coordinates, we get the following result, and we can find that the changing port can be detected. However, we also can find the following phenomenon. The first 3 points, there are some very slight change, but this change is rare happened, but it can only be reflected by the Fractal analysis of volumetric coordinates rather than volumetric vector similarity measure built here. In this slide, in this part, we can't find that. So, therefore, slight change can only be reflected by the Fractal analysis of volumetric coordinates. And this could be an advantage of our reference method. This slide reveals the data processing results of EXS error plot. And from this slide, we can find that compared with Fractal analysis of volumetric coordinates, Fractal analysis results of the measure cosine and area, the 2 parameters, the right changing port can all be detected. However, for the volumetric coordinates, for the G parameter, it doesn't work. So therefore, the Fractal analysis of cosine and area should clearly change. But when we discuss the effects of the vector symmetry measure, in this figure, we can find the cosine and area perform better than the module and the volume parameters. And the similar conclusion can be drawn from the another pseudo fault UIX when using the same data processing. To comprehensively evaluate the performance of our proposed method and the reference methods, we made a statistic on the final recognition results, where Y stands for the successful recognition results and this logo stands for the wrong recognition results. To discuss the effects of the vector similarity measure on the first recognition, towards the 3 mentioned faults, area and volume, the 2 vector similarity measure perform better and they are more robust because more Y sign could be found in method 1, rather than the module and the cosine measures. When it's coming to the performance of the Fractal analysis measures, we can find that under the setup of the Fractal analysis index measure perform better. Using the index and the vertex symmetry measure area and volume, they are more robust than the another setups. Similar result can be found here. After this research, we get the following results. Fractal analysis parameters are extracted from the volumetric error vector symmetry measures. As for the comparison, Fractal analysis are also extracted from the volumetric error vector components. And in this research, area and pseudo faults are tested. Fractal analysis of volumetric error vector similarity measure have excellent performance for fault sensitivity. For the area and volume measure perform better than the module and cosine measure in Fractal analysis. And although Fractal analysis of volumetric error coordinates contain the compulsory volumetric information, and it can reveal the minor fluctuation of the normal states. However, as for the Fractal analysis of the vector symmetry measure is count. But Fractal analysis of volumetric error vector symmetry error can also be monitored using the simple control chart for the machine condition monitoring. Welcome for your comment and suggestion. Thank you.